In this video, we are going to explore the main branches of machine learning, that is supervised and unsupervised learning. If you are just starting out with machine learning, you are in the right place. Understanding the differences between these two types of learning will help you to understand how machines learn from data, whether it's recognizing faces in photos, recommending movies, or understanding customer behavior. By the end of this video, you will learn what is supervised and unsupervised learning, what kind of data each uses, real-world examples of both, and which algorithms are commonly used in each type. So if these terms have ever confused you, I will explain everything in a simple, clear, and practical way. So let's get started. Branches of machine learning. Machine learning is generally categorized into three branches: supervised, unsupervised, and reinforcement learning. However, in this video, we will focus only the first two, supervised and unsupervised learning. To understand the supervised and unsupervised learning, we first need to understand the difference between labeled and unlabeled data. Labeled data includes both input features and their corresponding correct outputs, that is labels, which guides the learning process. So simply I will say that each input has known output. For example, if you show a picture of dog and say this is a dog, you are giving the model both image as input and the label as output. Okay. Next is the unlabeled data. Unlabeled data contains only input features without any predefined labels, and the model tries to discover hidden patterns on its own. In short, you can say that labeled data is learning with answers and unlabeled data is learning without answers. So look at this. I put the image of dog and also give the label as it is dog, and the image of cat and label as well as it's a cat. So this is the example of labeled data. But on the other hand, if you look at the unlabeled data, there are no labels. So this is a major difference between both of these labeled and unlabeled data. So let's visualize the difference with the table. First, we have labeled data. Each flower has its features like petal length and also species names like iris, setosa. And in the next table, we have the same feature but no species name. This is the example of unlabeled data. So let's now talk about supervised learning. Supervised learning involves training a model using labeled data to uncover hidden patterns and relationship between input variables as feature and output variables known as labels or target. Okay. So you can say that in supervised learning, the machine is trained using labeled data, meaning it gets input and output pairs and learns to find a connection between them. Once trained, it can make prediction on new unseen data. So here are some popular examples of supervised machine learning. Disease prediction, predicting diseases from patient data. Next is the image classification, identifying animals, objects or peoples in pictures. And then recommender system, YouTube, Netflix, suggesting you movies or videos based on your past behavior. Traffic predictions used by Google Maps, predicting traffic using past data and current road conditions. So supervised learning is further divided into two categories, that is classification and regression. First, let's have a look at classification. Classification is a supervised learning where the goal is to predict a category, a label, that is classifying email as spam or not spam. Okay, so you can say that in classification, model predicts a category or class based on the input data. Okay, as I give the example of email spam detection. Algorithm will detect is this a email a spam or not spam. Similarly, disease diagnostic predict if a patient has a diabetes or no diabetes. Next is the sentiment analysis, determine if a tweet is positive, neutral or negative. So this is the example of classification under the supervised learning. So here are some popular algorithms: decision tree classifier, random forest classifier, k-nearest neighbor classifier, or sport vector machine classifier, and many more. Each of these has its own strengths depending on the data size, type, accuracy and needs. So it is not necessary that every algorithm will work on every data. So every data has its own nature, its own structure. So it is not possible that every algorithm will work perfectly on each data. And next is the regression. Regression is a supervised learning task where the goal is to predict a continuous numerical value, predicting house prices based on sizes. So what is the major difference between classification and regression is, so in regression the model predicts a continuous numerical value instead of a category. Popular examples are house price prediction, predict house prices based on feature like size and location. Car price prediction, predict used car prices based on age, model or mileage. Similarly, salary prediction. So these are the popular algorithm of supervised learning and main branches of supervised learning. So now let's shift to unsupervised learning. Unsupervised learning is a type of machine learning where model is trained on unlabeled data. The goal is to find hidden patterns, structures, or relationship within the data. So in unsupervised learning, data has no labels. Machine is only given input data and it has to discover patterns or group on its own. Some real life example includes customer segmentation, group customer based on the purchasing behavior or demographics, employees performance clustering, cluster employee based on the performance, matrices for HR decision. Similarly, documents clustering, group similar documents or articles for better organization. Here are some popular algorithm: clustering, hierarchical clustering, Gaussian matrix model, PCA and TSNE. These are only popular. There are plenty of algorithm available for supervised and unsupervised learning. Let's make this even more relatable with a simple example. Imagine John is listening to a song. Each song has certain features like vocals, tempo, intensity, and genre. Now, if we have a dataset of many songs with these features but no labels, that is, we don't know if John liked them or not, we can use unsupervised learning to group similar songs together. Later, we might discover that one group mostly includes songs John tends to like, even though we never label them as like or dislike in advance. So let's have a look at this. There are clearly two clusters, one with songs he likes and another with songs he dislikes. So by applying unsupervised machine learning algorithm, it can be easy to predict that John will like or dislike a new unseen song based on the vocals, tempo, intensity and genre. So this is the video about the comparison of supervised and unsupervised machine learning algorithm. But still, if you have any question, feel free to ask in the comment section and don't forget to subscribe my channel. Thank you.